Hey guys, it's Shelly. I'm here with another fireside chat. Just kidding, better late than never. I'm here to talk about run charts. So I'm going to share my screen with you. We're going to take a look at this template. I actually spent some time building templates straight from Excel, and there's parts of it that are easy and parts of it that are challenging. So for this video, I decided to use this pre-made template. I worked out this data ahead of time, but I will walk you through the process of what it means and how to work with it, and then we will analyze the data after the fact. So you can see here, it's set up to put in your vertical axis label, which for me is going to be number of daily tardies. And then my graph label is average number of daily tardies per month in the year 2021. So if you look down into my chart for the data observation, I've labeled the months of the school year from August through May, and then entered the number of average tardies, daily tardies per month. And you can notice that there's quite a bit of a variety running from 55 to 95. At that point, the median is determined, which was 65, and a goal was set for 30. So let's move over to the chart. You can actually go in and adjust the chart for a number of things. For instance, you could change the label on either axis. You could put a label on this x-axis, but I chose not to, simply because it's pretty obvious that you're looking at months of the year for the course of a school year. Someone in the non-educational realm or someone that wasn't a parent might need some further explanation, but for those of us in the school world, we know that August through May is a school year, and you can see that each month is labeled continuously. This is important for a rate chart because there needs to be no break in time. When I created this chart initially, it had labels all the way from 0 to 100, counting by tens. And what that did was create entirely too much space, too much white space in the chart. So I went through and formatted the axis, and I changed my maximum. Well, I left my maximum at 100. And then I reset my major units, and this is the increments in which it counts, to 25. So you can see that went from 0 to 100 by tens, so now I have 0 to 100 by 25s. It's still easy enough that you can access the data and determine where things are. If you needed specific labels, we could go in and we could label each one of these dots, which is called a marker. We could label the markers and you would know exactly where they are. But based on our median of 65, and this is our center line or our median of 65, we can see where markers are above or beyond. Our goal of 30 means that we want to see a downward trend in the number of tardies per month. And in education, we know that that is the goal, is to decrease tardies for the purpose of increasing ADA, and also for the purpose of getting kids in class to maximize instructional time. So each of the points from here is mapped out onto the chart. You can see August at 70, and here's August at 70. And this went through and looked at the entire school year. So what does all this data mean? Well, first, before we even look at that, we need to determine why we are doing this, or state the purpose for doing this. And what we want to do is answer a question. And the question for this chart is, does the change in number of daily tardies change over the course of a school year? does the change in the number of daily tardies change over the course of a school year? So we are looking for significant trends and patterns. So for PDSAs, which aren't specifically labeled on this chart, in trying to reduce the number of tardies, PDSAs would be good attendance incentives, prizes, competitions, whatever a school typically does to lower the number of tardies or absences. In which case we would label a PDSA, and then we would look at the change in between the starting time and the PDSA, and then what happens afterwards to see if this PDSA or intervention was actually effective in reducing the number of tardies. We don't have that here, so we will just go with the information we have. So back to the median line, this is the average number of tardies across the school year. So you can see it is right at 65. So now let's look at some critical points. First, I'm going to start off with this astronomical point, which is an outlier. And you will see that it is May. And whereas tardies have been running in between the 50s and the 70s, here in May, your tardies show up at 95. Well, as educators, we know that in May, kids are getting excited about being out of school and they're less involved and they're less engaged. And typically they're coming to school later and later and missing more. So that would explain why we have this outlier or this astronomical value. The next thing we want to look at is runs. And a run is where one or more points occurs either above or below the median line or the center line, not counting the points on the line. So we have 1, 2, 3, 4, 5, 6. We have 6 runs in this chart. Now, we would normally be looking for shifts and trends. And again, as educators, we know that typically there's a shift in attendance towards the end of the year. There's a shift in tardies towards the end of the year. As the days go on and on closer to the school year's end, your number of points go up. But for the purpose of this, all we're looking at is what we statistically have in front of us. So a shift is where you have 6 points on one side or the other side, like a run of 6 points, either above or below the median line, to indicate a change or a pattern. And as you can see here, again, points or markers on the median line don't count. So I'm looking through all of my runs, and none of my runs have 6 or more points, so there are no shifts. Now, a trend is the same sort of concept as a shift, except we're looking at 5 points. And again, because of our limited data set, we only have 10 collection points here, or 10 increments in which we're taking attendance and figuring out numbers. There is no run of 5 or more, so we have 0 trends. The next thing we would need to look at is our upper and lower limits for runs. And so too few or too many runs has to look at whether or not you have non-random variation or random variation. If you have too few or too many runs, then you're looking at non-random variation. If you fall within the limits of allowable runs, then you have a random variation. So to determine this, for our upper limits, we are going to look at the number of markers that we have that are not on the median or center line. And if you count these, we have 8. And from 8, we're going to subtract the number of points that are exactly, or the number of markers that are exactly on the median or center line, which are 2. So 8 minus 2 equals 6. So What are we looking at? Well, the next thing that we want to look at we want to look at runs that cross the center line and see how many times the center line or the median line is crossed, which in this case would be 4, and then we add 1, which is 5. So we are looking at limits of 5 to 6. And then typically what you would do is pull up a run table, which you can Google, and there are random variations, but typically for 10 data points, the limits are between 3 and 8 or 3 and 9, and neither one of these numbers fall outside of that range. So we know that we do not have too few, nor do we have too many runs, and we're looking at a random variation. Join me next time when we explain a little bit more.